Welcome to this beginner-friendly tutorial on custom frame rate control and delta time adjustments in Unity 3D. Whether you're new to game development or looking to optimize your projects, understanding these core concepts will help you create smoother, more efficient, and more responsive games. Today, we'll cover the fundamental basics, provide clear step-by-step demonstrations within both Unity and Visual Studio, and share invaluable helpful tips along the way. Our goal is to equip you with the knowledge to build games that perform consistently across various platforms and hardware configurations. Pro tip: always test your games on different hardware to see precisely how varying frame rates affect overall performance and user experience. Let's begin our journey into game optimization. First, what exactly is frame rate? Frame rate, often abbreviated as FPS, which stands for frames per second, is a crucial metric that measures how many individual images your game engine renders and displays each second. A higher FPS directly translates to smoother, more fluid visuals, making the game feel more responsive and immersive for the player. However, achieving a consistently high FPS can significantly strain your computer's hardware, particularly the CPU and GPU, leading to increased power consumption and heat generation. By default, Unity often attempts to render frames as fast as possible, resulting in an unlimited FPS, which can be inconsistent across different machines. To ensure a consistent experience, we can actively control this frame rate. This involves understanding concepts like VSync and setting a target FPS. VSync helps prevent screen tearing by synchronizing the game's frame rate with your monitor's refresh rate, but it can introduce input lag. Helpful tip: for most games, aiming for a consistent 60 FPS is considered the sweet spot. It provides excellent visual smoothness without excessively overheating devices or draining battery life. Now, let's dive into the practical steps of setting custom frame rates directly within your Unity project. Step 1. Begin by opening your Unity project. Once loaded, navigate to the Edit menu at the top, then select Project Settings, and finally click on Quality. Within the quality settings, locate the VSync count option. To gain manual control over your frame rate, set this option to Don't Sync. Step 2. Next, we'll implement the frame rate control through a C# script. In your Assets folder, create a new C# script and name it Frame Rate Controller. Inside this script, you will use the line application .targetFrameRate equals 60 to explicitly lock your game's frame rate at 60 FPS. For robust control, especially if the target frame rate might be reset, consider this snippet. Update if application.targetFrameRate equals 60. Step 3. Once your script is ready, attach it to an empty game object within your scene. This ensures the script runs as soon as the game starts. Then, play the scene and observe the stats window. You should see your game's FPS consistently holding at the target of 60 frames per second. To efficiently edit your C# scripts, double-click them directly in Unity to open them in Visual Studio, which offers powerful coding features. Ensure you have Visual Studio tools for Unity installed. You can verify or install this by navigating to Tools, Get Tools and Features within Visual Studio. Pro tip: for mobile games, consider using quality settings.vSync count equals false to save battery life, but always monitor device heat during testing. Now, let's shift our focus to another critical concept in game development: delta time. What is delta time? It represents the time in seconds that has elapsed between the completion of the previous frame and the start of the current frame. In Unity, this value is conveniently accessed through time.deltatime. It's a small but incredibly powerful variable. The primary purpose of delta time is to make all movements, animations, and physics calculations in your game frame rate independent. This means your game will run consistently, and objects will move at the same speed, regardless of whether the player has a high-end gaming PC or a more modest laptop. Without the proper application of delta time, objects on faster hardware would appear to move at an accelerated pace, while on slower hardware, they would crawl. Helpful tip: while time.deltatime is excellent for general updates, use time.fixeddeltatime specifically for physics updates. This ensures stable and predictable physics simulations, preventing jitter or unexpected behavior. Now, let's explore how to effectively adjust and utilize delta time within your Unity projects, integrating with Visual Studio for precise control. Step 1. For smooth, frame rate independent movement. You'll typically multiply your movement vector by a speed variable and then by time.deltatime. This scales the movement by the actual time passed since the last frame, ensuring consistent speed regardless of FPS fluctuations. Demo in Visual Studio. Open your movement script. Write this code, leveraging IntelliSense for quick and accurate completion of time.deltatime. Once the code is written, save your script, build your project if necessary, and return to the Unity editor. Step 2. For custom adjustments to the game's overall speed, you can modify time.timescale. Setting time.timescale equals 0.5f, for instance, will slow down the entire game by half, affecting all time-dependent operations. For physics-specific adjustments, you'll use time.fixeddeltatime. This is configured in Unity's Project Settings under the Time section. Adjusting the fixed time step value here directly impacts how frequently physics calculations are performed, crucial for stable simulations. Step 3. To test these adjustments, create a simple scene with a basic moving cube. Attach your movement script to it. Enter play mode and observe the cube's movement. Experiment with different time.timescale values or fixed time step settings to see their immediate effects. For deeper analysis, Visual Studio allows you to debug by setting breakpoints on lines involving delta time to inspect its value during runtime. Additionally, Unity's Profiler, accessible via Window, Analysis, Profiler, is an invaluable tool for monitoring frame times and identifying performance bottlenecks related to delta time. Pro tip: if you notice delta time spikes causing jittery movement, your first course of action should often be to cap your FPS. Uncapped frame rates are a frequent root cause of such inconsistencies. Let's now discuss common pitfalls developers encounter and some advanced tips to further optimize your game's performance. One significant pitfall is simply forgetting to use delta time for movement and calculations. This inevitably leads to inconsistent speeds across different machines. Another common issue is uncapped FPS on low-end devices, which can quickly drain battery life and cause devices to overheat. Always conduct thorough testing on a range of target devices to identify and mitigate these performance issues early. For advanced scenarios, especially in multiplayer games, it's crucial to synchronize delta time assumptions across all clients to maintain consistent game state. Additionally, for UI elements that should remain unaffected by time.timescale, always use time.unscaleddeltatime. Tip 1. Make profiling an integral part of your development workflow from the very beginning. Profile early and often to catch issues. Tip 2. For team projects, meticulously document your frame rate and delta time settings. This ensures consistency and clarity for all team members. You've now gained a comprehensive understanding of custom frame rate control and delta time adjustments in Unity and Visual Studio. These techniques are fundamental for creating polished, high-performance games that deliver a consistent and enjoyable experience for every player. We encourage you to practice these steps diligently in your next game development project to solidify your understanding and enhance your skills. If you have further questions or wish to delve deeper, Unity's official documentation is an excellent resource. You can also explore Unity Learn for more tutorials and community forums for support. Thank you for watching this tutorial. We hope it empowers you to create even better, more optimized games. Happy developing!